Hi, welcome again. Our last video was abruptly interrupted by Camtasia, which is the application we use for the video recording. Well, everything was saved, and the file that we have, we can reopen. So we go here in Files, and then let's open the project. The project's already there. The name of the project is this, burglar alarm, if you remember. And we need to use this. This is the QPF. This is a project file that we are building, and this is the procedure to reload the same file. So we are loading now the project into QuartusII. We leave that intact. I did not change anything from the interruption. So we were supposed to be able to continue from that point. So see that now we can see the burglar alarm. If I double click here, I'm supposed to see back, you see, my burglar BDF. Okay, so we have pretty much this connection finished. And this is the one in which I have the ARM circuit in one. I have also the, let me see, this is the ARM, and I don't think that's, have to get rid of that, okay? Because the ARM goes here, here, and here. Something got wrong in the, in the last video that I connected. This should go then, this is the one that we're missing. It should go to Windows, right? Because the door is already inverted coming into here, and this is the one that will correspond to Windows, okay? Let me see, no, I was wrong, so back again. This is a good thing about this, that you can so this is the Windows. Very good. Now, this will go to Windows in inverse, so we can type that to Windows, which is this, okay? So Windows here, and we're supposed to go the same thing. And if that goes from alarm and the Windows inverted, then this one is supposed to go to the door, but not inverted, and it will go straight to the door. So let's see. One thing I forgot to tell you is, let me see. Let's just Control C and we need to connect that back in with the door, right? No, we need to connect that is with this, which is Windows. So nope, it should be with the door, right? Okay. So yeah, we can check. So we have this connected from ARM. This is the first of the inputs. Then the second one is connected to Windows, and the other one connected to the invert of door. This one, ARM, the first one is okay. The second one is inverted from Windows, okay? And the third one should be straight from door, okay? And this one is straight from ARM, from door and straight from all of them. Okay, now we save that. Okay, the next step should be compiling. Compiling means that this diagram is going to be converted into intermediate file. So all the inputs and outputs and functionality will be then described in a very different form, in form of a code. Now, this is very important. See, these windows over here is the compilation, and we're setting even is in faded, but it's compilation. Now this is a process of compilation. First, we are analyzing the integrity of the circuit to see whether all the symbols are correct. And then we're compiling. At the same time, we're doing a physical fitting of all these gates that we're using, translating into the physical, what would be the physical instance of each one of these components that we have there, and the connections, and the signals, and the inputs, and everything, right? All right, so the thing is that everything was successful. We have this check mark in green. If not, well, you get some errors, and you see them in red. And you can read the errors on the bottom. This is the message windows. Every message, everything that happens is use these windows to show the message. Perfect. So we already compiled. That means that we're ready to do a functionality simulation, right? How do we do that? Well, we go here into Files, and then we say New. We're going to be using here in Verification and Debugging Files, we go into University Program, VWF, and we click there, and we open a new screen. That would be the new screen. All right. This is essentially a simulator. So we want to, for our design, and you see that when we call that on the top of the simulation bar, we see our name here as burglar alarm, and then we are doing a file. It's VWF. It's very simple. It's very basic, but for what we're doing, it's just fine. All right. So the first thing we need to do is bring all the inputs and outputs that we want to be using, because our interest, remember, is to show that this circuit works okay. Works okay with the truth table. So we want to build the truth table that we showed in the diagram, and then we want to try to see if this is exactly the same way. So the only thing is that the truth table will be shown in terms of a time diagram. All right? Good. So one thing that we may see is that there is a limit in terms of the time that we're using. So we usually from 0 to 1,000 nanoseconds. Okay? So remember, if for this case, our truth table has 3 inputs. So remember that we are going to see only 8 different rows. Okay, so in other words, possible combination of those 3 inputs gives me 8 different combinations. So remember, I'm going to be describing all possible combinations with time. And then I have to divide this time frame into at least 8. Okay? We, for instance, can say, oh, I can do that and just say, well, from 0 to 800. and then 10 nanoseconds per each one. Well, that would do it perfectly okay. Right. We can leave that for later, right? Now we go here into edit, and then we want to insert nodes, okay? And then this is what we have this. Okay, we can type, for instance, say, oh, I want to bring alarm or windows or door. But it is easier if we go like this and say, okay, no finder, and then I have another screen and say, okay, list. Again, I want to ask to tell me what are the nodes that we use. Say, please list everything. Say, list here, and then I have all inputs, right? And the output together. If I want to see this, for this circuit, it's not a problem because it's very simple. We'll have 3 inputs and 1 output. But imagine those circuits in which we have many inputs, many outputs, internal signals, and all that. Those are a part of the nodes, by the way. Input, outputs, and internal signal. Well, but they say, okay, we can one by one check. They say, okay, I want this, but I can say no. I want everything, right? And everything is here. I say, okay, right? Okay, okay. So see that the output here is shown with X. In other words, we don't know what the number is, right? So what can we do? Well, we don't do anything. The output's gonna be subject to the different inputs that we have to change. All right, I can arrange that in such way that I bring this up. So I mark that and then keep my bottom press, right? And I can say, okay, for instance, in this case, I want the door on top of ARM, and then have the windows, and then the doors, and then ARM. And the reason for that is because if you remember the truth table, this element here is the one that I change the least frequently. So it changes every 4. I can use either the windows or the door to change that. So remember, we could use if we have from 0 to 1,000 nanoseconds, we can use for each one like a 20, let's see, 800, 200 nanoseconds for each one of the transitions. Now, one thing I can do is say, okay, Windows. I mark Windows with the mouse, and I say, you see this symbol here? I could say, for instance, I want this Windows to be, if I mark that, to be high, and then it makes a high for us. Or I can say, well, the Windows, right? I want to have a pattern that is, I press this, C is a count value, right? This count value is going to be doing like a clock, 0, 1, 0, 1, 0, 1, 0, 1. And it's incremented by 1. Each transition is 10 nanoseconds. So see, if I do 10 nanoseconds, I'm basically not going to see anything that happens here. So let's see, if I go OK, then that will be the count of the 10 nanoseconds. I don't want that. I want something more like a slightly bigger. So we can say, okay, well, let's try and see if we cover everything with 100 nanoseconds. Well, 1, 2, 3, 4, 5, 6, 7, 8 transition. But that's perfect because this guy, remember, this is the one that I have closest to the right in the truth table, and it changes every time. 0, 1, 0, 1, 0, 1, 0, 1. Now the door, I'm going to do the same thing with the door. I'm going to mark the door first, then go to the count, and they say, okay, increment by 1, but I don't want it. I want this to change every 200, which is the double of what we have before. Say, okay, and you see, I have 0 here and 1. In the meantime, this remain in 0, so that when this changes 0, 1, this stays 0, 0, and then 1, 1, and then 0, 0, and so on. And last, the armed, I do the same thing. I ask for account type. I say, okay, last one, 200. I want this to be double, so 400. Okay? And this is perfect because I have now all the elements of my truth table. See, if I read the truth table, I see the Windows 0 at this point, Windows 0, and I can have this guy here as a pointer, 0, 0, 0. In this case, I can read that as a 0, 0, 1. This is 0, 1, 0. This is 0, 1, 1, and so on and so forth. So I'm just doing my truth table until we get up to here, which is 1, 1, 1. Perfect. We're good. Now, what else we need to do? Well, we need to simulate. Okay. So the simulation simply would take for our circuit these inputs and then produce the output. Okay. Now, we can here go into run functional simulator or timing simulation, where there's a difference. For now, I'm saying that we should stay in the simple side. Okay, simple. That we're not getting into effects of time of anything. So we're interested in functional simulator, right? Then we click here, and then they say, oh, the waveform has, okay, yes, we change that, and then we save as we can say the name burglar burglar alarm. Okay. All right, and then it starts doing processing there. Okay, so and then finally it runs this model for us, and this is the result. And this is perfect. It works just fine. See, this is the alarm. Okay, it shows pin name B1, but this is the alarm, the output. I don't know why it doesn't take the name. I have to check that. I presume that that's the way we select the pins, but that's fine. For now, let's see that their result is perfect. See that this is our truth table, 0, 0, 0, 0, and in the meantime, while the arm is 0, see that the output is 0. Arm is 1 from here to here. However, none of these two sensors are 1. Therefore, is 0. So we have arm, but no one has tried to enter. But now, from here up to here, is when we have this arm in 1, either the windows or the door or both are on, and therefore our arm is on. Okay, so see that this is what, for instance, if you want to report the behavior of this circuit, well, that would be enough. Now, there's a problem with this. It doesn't allow us to print or anything like that. But what can we do? We can do then a print screen, right? We print screen, right? And then we cut and we save into a Word document, right? Good. So this is pretty much how the this Quartus II works. One thing that we need to remember is This is the basic diagram of what we have. Of course, this is the reason I didn't put alarm here. I should use the alarm. Okay. This is, for instance, if this is the case in which some changes come, but I have to do a save everything now, save everything, and then compile again. Right? I have to compile because even though it's a name, everything was changed. Right? To see the same process, start doing that analysis and synthesis, and it goes, right? So that was the reason why the name of the pin was not there, because I didn't save, I didn't change the name for that. But you're gonna see what exactly is that. And with that, I'm gonna kind of repeat the process of doing the simulation. Okay, so as you can see, this is a very versatile tool. As I said, this is exactly the same tool that is used in most big companies that deal with digital designs. Of course, for that particular brand, Altera, but it's kind of half of the market. The other one is Xilinx. Xilinx has something similar, but in this case, we have been using Altera for many reasons. I think that's more. I think they have the boards that are better educative type of boards. Right. Now we finish this, and then if you remember what we need to do, we go into a new file here, University Program BWF, right? And this is what we have. Now it's called Waveform 2. What else is that we did? Well, we remember we did edit, and then we insert bus, right? And then we go into node finders. And then here's the node finders, and then we ask for the list. Now we have the output is still. It didn't change the name. I don't know why. Okay. I'll find the reason for that, but okay. So you know pretty much what is the way to do things in here. Okay, next. For now, you have all basic whatever you require basically to start working with the Quartus II. As I said, you have the instruction manual. It's a PDF that is available for you, and you also have a lot of documentation if you go to Altera Altera page. Okay, let me give you. Okay, if you go and search for Altera. Okay. Okay, they have some things, but here you have all type of documentation, download center. This is what we need to go. There's a specific set of instructions to download the Altera. By the way, remember that we have two different products. So the Quartus II subscription. This is not the one that you're gonna get. You're gonna get this one, the Quartus II Web Edition. All right, this is the one that is free, and that's the one that you need to download. Versions for that, there are more than one. You see, this is 14.1. 14.1 is only for 64 bits, but 13.1 will work just fine. Okay, so this is Quartus II Web Edition. That's the one that you need, and you should download all the files, including the model sim. This is the simulator that we have. Okay, when you try to download the files, you will download a module that Akaima, this one, Akaima DML download manager. Okay, it's much better. You download that first, and then it will take care of the complete the download processing, and everything will be fine. So remember, first of all, 14.1 is a good release. It's the one that I'm using here in the office, but at home I'm using 13.1 because my computer at home is 32 bits. But this is fine for 64 bits. Most of the computers nowadays are 64. So this is a much newer release and all that. Remember, it's okay to download everything. When you download, it will ask you for your password, and you have to subscribe to Altera because we're under the university program. Okay, so there's a specific instruction for downloading. I probably have a video specific for that, but for now, again, what the interest is you to know how to use the tool. Okay, remember always to save, and if you want, this file can be printed. Okay, so you can do a print preview, and it's not clear here, but so I'd rather you to go and do the print screen, then cut and then paste into a Word. That will work much better for the report. All right, so please let me know if you have any comments about this. Check this. It may be may have some. I think the diagram that we had before the abrupt interruption has some errors here, but please check this yourself and see if you can. Now I can. I probably once I release this, I did that. Let's see now. That may be the reason. See what happens when I click on that. It'll show. All right. Well, anyways, I'm over 28 minutes, and I don't want to have the same problems with the Altera. All right. So it's coming. Let's see. Let's hope that nothing happens. If not, well. So see here, we have all steps until we are ready to download this into a chip. Okay, good. So remember what we did was, again, new university program, right? And then get the nodes, insert nodes and pause. And let's go to the node finder, list everything, and alarm. Okay, now it shows the name. Okay, very good. So I want to leave you here, and then as I said, there should be more videos for this purpose. All right, for downloading and for the documentation. Again, you will have this introduction to Quartus II in diagram input, okay, or schematics entry, and that'll be all. Thank you so much.